Hello and welcome. In this video, I will introduce you to MVTec MERLIC's deep learning-based Detect Anomalies tool. For this, we are taking a closer look at the MERLIC example Detect Anomalies of Bottles.mv app. The goal of this example application is to inspect glass bottles and detect defects like these. But first, what is anomaly detection? Anomaly detection, at its core, is a binary classification, which means an input gets assigned to either one of two classes. You input an image, and the anomaly detection will tell you if it's good or bad. It's based on unsupervised learning. Only one of the two classes must be trained. The other one is an implicit rejection class. Therefore, elaborate labeling is not needed. The trained class is referred to as good, and the implicit rejection class as bad. The use case of anomaly detection in MERLIC is to find local anomalies. It is especially useful for applications where you have many good samples, but the defects are rare and diverse. Anomaly detection requires only a small number of images to train its model. In some cases, as few as 20 images are sufficient. This makes anomaly detection easy to train and quick to prototype. The image source tool is for the image acquisition. The tools Determine Alignment with Matching and Align Image are used to pre-process the images for the Detect Anomalies tool. The Detect Anomalies tool performs the anomaly detection. Note its quick info, where you can find an overview on how to use the Detect Anomalies tool. MERLIC supports both CPUs and GPUs as processing devices. For this tutorial, I changed up the example in a minor way. These changes were made to show you how to train and apply an anomaly detection model within MVTec MERLIC. I deleted the already trained anomaly detection model and configured the image source tool for the acquisition of the training data. Additionally, I split the training data into good and bad images. Bad images aren't needed for training, but they can significantly improve the result of the anomaly detection. Now let's start the configuration of the Detect Anomalies tool. First, we must train our anomaly detection model. For this, we must select the folder containing the good training data within the image source tool. We start our training by going into the Detect Anomalies tool and adding the data one by one to our training. You can either click the plus button right here or press the F3 key on your keyboard and label it right after. You go through your data by clicking Execute MERLIC Vision App once or by pressing F6 on your keyboard. Do this for every image until you encounter images you've already inserted into the training. Data you've already added to the training is marked as inserted. Duplicated or unwanted data can be deleted from the training via the X button. After successfully adding all images to the training set, we can train our anomaly detection model. This might take a while. For the inference, we change our image source to the folder containing the processed data. In the Detect Anomalies tool, you can now see the processing of the images. As a result, you get a heat map and the Boolean anomaly detected in the bottom left corner. Here you can also step through the inference images one by one, clicking Execute MERLIC Vision App once or pressing F6 on your keyboard. As you can see, the application is already pretty good at detecting anomalies. But to make it even better, we change our image source to the folder containing our bad training data. We go back into the anomaly detection tool and start adding our bad images to the training set, just like we learned before. Afterwards, we train our anomaly detection model once more. These bad images are technically not used for training, but to evaluate the anomaly model, which results in better adapted anomaly thresholds. This means that the anomaly detection is better at deciding whether images contain anomalies or not. For a final look at our application, we change our image source back to the folder containing the processing data. To better visualize our program, I set up a small front end, exactly like the one inside the example Detect Anomalies of Bottles.mv app. As we look at our front end, you can clearly see which images contain anomalies. Anomalies are indicated by a red light. Additionally, the heat map shows where exactly those anomalies are. The applications of anomaly detection are countless. Other examples would be the inspection of solder joints or checking for defects in wood. This concludes this video. You should now be able to navigate through the example Detect Anomalies of Bottles.mv app and adapt it according to your application. If you have feedback for us regarding MERLIC, feel free to send it to us via the feedback button in the top right corner. Thank you for watching.